Hello. Today we're going to talk about the lymphatic system. So let's take a look at this diagram. Hopefully it looks familiar to you. We have a red artery coming from the heart and then branching down into smaller and smaller arteries until eventually it becomes an arteriole, the smallest artery. And then the blood is going to enter a capillary where we can see the gas exchanges occurring. So oxygen is getting dropped off, and then the deoxygenated blood is leaving the capillary bed, entering a venule where it will enter a larger vein, and then eventually get back to the heart. One part that we haven't mentioned yet is think about the size difference from this arteriole to this capillary. Like the arteriole is larger than the tiny microscopic capillary. So imagine what it's like when this arteriole is trying to kind of force blood into the capillary. It'd be kind of like a traffic jam. You have something and you're trying to force it into a smaller place. Capillaries are very permeable, and what ends up happening is a bunch of the stuff accidentally leaks out of them. The red blood cells and the white blood cells are too big, so mainly plasma leaks out as we're going from this high pressure system into this lower pressure system, forces all this plasma out. Down here at the venous end, a lot of the plasma is reabsorbed and then taken back in, but not all of it. So about 20 liters are forced out at the end of the artery, and 17 liters are reabsorbed at the venous end, and that leaves us with 3 liters of liquid just sitting on our tissues. That's not good. And that's where our lymphatic system comes in. So its job is to collect all that plasma that leaks out, and then it actually returns it to the heart so it keeps our blood volume constant. And our immune system lives inside our lymphatic system. So while it's getting returned to the heart, it also gets kind of cleansed and filtered. Here is another view of a capillary bed, but this one is so that we can actually see how the lymphatic capillaries are kind of like interwoven in between all the other capillaries and how they're able to absorb the leaked plasma. So let's take a look at this lymphatic capillary. The first thing I notice is that these cells kind of remind me of like shingles. They're just sort of like loosely overlapping epithelial cells, and that allows the lymph, the leaked plasma, to be able to enter in through the overlap between the cells. So once the plasma is inside of the capillary, we can officially call it lymph. And this gap right here between the overlapping epithelial cells is called a flap-like mini valve. Here is another picture of that. So here is our little flap-like mini valve, but this picture, the capillary is cut open so that you can actually see the valves on the inside. So lymphatic vessels are similar to veins. They're kind of like low pressure systems, and they need valves to be able to prevent the backflow. And this is a pretty simple but like clever system. So when the pressure out here is high, because there is a lot of leaked plasma, it forces the plasma to slip in through the flap-like mini valves. Then once all the plasma comes in, the pressure inside is higher, and that forces the flap-like mini valves closed, preventing any of the plasma from being able to leak back out. And this is our view from the outside, and then it's going to make its way traveling back towards the heart. Here is a kind of overview of the whole lymphatic system, but still, I guess, sort of like symbolic. So here we have our lymphatic capillaries, like we've already been talking about. And similar to arteries and veins, the lymphatic capillaries are going to converge into larger vessels called lymphatic vessels or collecting vessels. And all of these little dots on the collecting vessels are lymph nodes. You've probably heard of those before, or maybe you've heard like, oh, I have swollen lymphs. So that's where these guys are. So all of these are vessels. Multiple vessels converge into what's called a trunk. I know it looks the same size, but it is slightly larger than the vessels. And then the trunks are going to dump into an opening that's called a duct, and that's how the fluid gets back into the heart. So the lymph is picked up by lymphatic capillaries, It travels through larger and larger vessels with nodes. Eventually, the vessels converge into even larger vessels called trunks. And then finally, the trunks are going to dump the lymph back into the heart, where it kind of meets up with the other red blood cells and white blood cells and becomes blood again. Here is an overview of the lymphatic system. This is just kind of like a general idea because the lymphatic system varies greatly from person to person. So, like, your lymphatic vessels are not necessarily in the same spot as my lymphatic vessels. And this diagram is trying to show us the difference between the two ducts. So the heart would be up here, and then this would be like the vena cava. It's not pictured. And the vena cava connects to the jugular vein, that like large vein in your neck. If you ever hear people say like, go for the jugular, like that's what they're talking about. And the lymphatic ducts actually enter the lymphatic vein, like right here and right here. So this part right here, that's kind of that weird light green color, all of this part of the body is drained by the right lymphatic duct. So the upper right side of the chest, the right arm, and the right half of the head, all of the lymph collected from this area of the body is going to re-enter the heart via the right lymphatic duct. And then the whole other, like 3/4 of the body, like both legs and the left arm and the left side of the head, are going to enter into the thoracic duct. Why? Mother Nature. The best answer that I can find is like while the embryo is developing, that's just how the vessels formed themselves. I know it's weird. And let's take a minute and think, how does the blood move through the body? Well, it's pumped by the heart. So how does the lymph move through the body? Where is its pump? There isn't one. So the lymphatic system has to move through the body without any sort of pump. That's why I have this picture here, because my dad actually has a small trampoline and he jumps up and down on it every day because he wants to circulate his lymph. Does physical activity move your lymph? Yes. Is it necessary to do that? Probably not, but that's his thing. He's a little weird. And the lymph is going to move the same way as blood moves through veins. So we didn't actually talk about how blood moves through veins very much, but when our skeletal muscles contract, like that pressure helps propel blood through veins, and it also helps propel the lymph through the lymph vessels. When we breathe, the pressure changes in our thoracic cavity in our chest. That helps be able to circulate lymph. Um, Also, the arteries that have a pulse where we are able to measure blood pressure, that's enough to encourage a little bit of lymph flow. And then the stuff that we already talked about, like, of course, the valves to be able to prevent any backflow. And then the lymphatic vessels are going to be structurally similar to veins, like with the three tunics. And remember, the tunica media is made of smooth muscle, so it can actually contract to help encourage the lymph to flow. Now let's take a closer look at a lymph node. So these were the little buttons that are kind of like dotted around all the lymphatic vessels. Lymph nodes are where the main part of our immune system lives. So like our white blood cells, our lymphocytes, our B cells and T cells. So I just said three synonyms for the same thing. White blood cells, aka lymphocytes, aka B cells and T cells. All of those cells live inside of this lymph node. So when the lymph enters over here and travels through it, it's going around all the white blood cells, and the white blood cells are like destroying pathogens and filtering it out. So cleaner lymph is able to leave. So the function of the lymph nodes is to filter the lymph on the way to the heart. And have you noticed a cool structure function relationship? How many afferent vessels do we have over here? Afferent means going in, counting 1, 2, 3, 4, 5. And then over here, we have 2 efferent vessels. So lymph nodes always have more afferent vessels and less efferent vessels. Why? Having more afferent vessels allows a lot of lymph to flow in, but then it can't flow out at the same rate. Like it essentially kind of creates a traffic jam where the lymph stagnates in here, and that gives it time for the white blood cells to do their thing. So because there are more afferent and fewer efferent, it slows down the flow of lymph and basically makes it stay in the lymph node longer so that it's time for it to get cleansed. What do you think this is a picture of? Do I have any history buffs? Those little things are called buboes, and that is the namesake for the bubonic plague. And would you like to think about what a bubos might be? It is an inflamed lymph node. So, kind of cool that even though nobody knows about the lymphatic system, it pretty much, inspired the whole bubonic plague. And you have probably felt your swollen lymph nodes more. We have more lymph nodes in areas where like a bunch of the vessels converge together. So like our axillary region, that's our armpits, our inguinal region, our groin, and our cervical region, which is our upper neck. And you can YouTube a video of like how to feel your lymph nodes if you're interested. Great. Thank you. Let me know what questions you have.